Hello everybody. Today I want to talk about some vocabulary. We're going to begin with talking about numerical expressions. A numerical expression is just a mathematical phrase involving only numbers and mathematical operations. So more precisely, there's no letters involved. It's only numbers and plus or minus or multiplication. There's only mathematical operations involved. By definition, an exponent is for example, the x raised to the n, and n indicates the number of times x is multiplied by itself. This is only true if n is a positive number. I want you to think about that for a second. When n is a positive integer in the expression x raised to the n indicates the number of times it's multiplied by itself, x is. So think about if I had x to the negative 2. Well, we know that x to the positive 2 means that I multiply x by itself twice, be x times x. But if I had x to the negative 2, what does that mean? You might have to think back to 8th grade math and rules of exponents. Maybe been a minute since we've done it. But that negative throws it down into the denominator. That's really the same as 1 over x raised to the second power. So that's why that definition specifies that if n is a positive number, a positive integer, then this indicates the number of times the x is multiplied by itself. What is a base? In a power, the number being multiplied by itself is the base. So if I have x to the third, my base is x. And that's telling me that I'm multiplying x by itself 3 times. And to evaluate is to find the value of an expression. So another question to ask yourself, what is the relationship between the exponent and the base? I kind of just clarified that. The exponent is the whole thing. It's the x raised to the n. The base is the big part of it. It's the big number that's being multiplied by itself. And what does it mean to evaluate something? You go to the doctor for an evaluation. What's that mean? They're looking over you, they're telling you if everything is okay, if there's something wrong. They're looking at you as a whole and giving you a report, right? So in math, what does it mean to evaluate something? Well, we look at the problem as a whole and we come up with a solution for it. We tell what it's the same as. We try to simplify it a little. So in today's lesson, we're going to look at some different things about evaluating exponents, evaluating numerical expressions. And the standards that we're going to cover is these two listed here. We're going to interpret complicated expressions by viewing one or more of their parts as a single entity. And we're going to use the structure of an expression to identify ways to rewrite it. So that sounds a little bit stuffy and sophisticated, but it's actually pretty simple. What we're going to be looking at is using order of operations. You guys have used order of operations quite a bit, I'm sure, in the past. Let's watch this little video.
Rob brought 2 12-packs of soda. Venus brought 3 6-packs of water. And Anna brought a pack of juice boxes. They are worried that they will not have enough drinks for the party and need to figure out how many they have altogether. They decide that there are too many drinks to count, so Venus suggests that they use the expression 2 times 12 plus 3 times 6 plus 10 to figure it out. Rob, Venus, and Anna each evaluate the expression on their own, but they all get different answers. Rob got 172 drinks. Venus calculated 480 drinks, and Anna's answer was only 52 drinks. They decide that they will have to count all the drinks to find out who was right. Anna was right. There are 52 drinks.
So let's think about this for a second. And we'll go back and pause it where they had the different numbers. I like, when I'm doing grading assignments, I like to not only look at what...
They decide that they will have to...
Hold on a second, I can't multitask
They decide that 52 drinks.
Okay, there we go. I don't want to just get the right answer, or I don't want to just know the right answer. I like to know what my students have done wrong. Because if I understand and you understand where you went wrong, then we can correct it, and that way we don't make that same mistake again. So looking at this, how in the world did they get 172 drinks and 48 drinks and 52 drinks? It's easy for us to count this because we see that Rob had two 12-packs. Well, we know right off the bat that two 12-packs is 24 drinks, right? So it's easy to see that Rob had 24 drinks. It's also easy to see that Venus had 3 6-packs of drinks. Well, 3 6-packs is 18. And then Anna just had the simple 10. So we have to add those that 24, that 18, and that 10 together, and we can quickly get 52. Now, if I'm any guess of things, I'm going to grab me a calculator here. I'm going to guess that Rob did 12 times 2 plus 3, and then multiplied that by 6, then added 10. Or maybe that was Venus that did that, but they didn't follow order of operations. Rather than multiply the 2 times 12 and get the 24, and then multiply the 3 times 6 and get the 18, then add all those numbers together. If I did 2 times 12, that gives me 24. Then I add 3. That gives me 27. If I multiply 27 by 6, that gives me 162. Then add 10, I get 172. So that's what Rob did. If you think about that, the 2 times 12 is 24, but then he's only adding 3 drinks to that. So 24 plus 3 is 27, and then he's taken that number and multiplying it by 6. Well, she didn't have 26 groups of 27 drinks. She had 3 groups of 6 drinks. So that's why we have to multiply first. So now let's take a look at writing some numerical expressions. Remember, a numerical expression just contains numbers and mathematical calculations like plus, addition, subtraction, minus. So it's a mathematical phrase that contains numbers and operations. For example, 6 plus 2 divided by 1 is a numerical expression. Look at the different ways that we can write 2 times 3. We can put the dot in the middle. We can use parentheses around the second one. We can use parentheses around the first. We can use parentheses around both of them. Previously, you've used an X in between. In Algebra 1, we try to refrain from using the X because then it gets confused as if we're using it as an unknown, like X is a variable and we don't know what we're solving for. And so that if you write it for a multiplication problem, somebody might look at that and think it's 2x instead of 2 times something. So we try not to write the X anymore in Algebra 1. So there's lots of different ways to write problems. Let's try an example here together. It says 1 plus 8 divided by 3. Okay, so we're going to think about this. We've got plus. What's another word for plus? We could use addition. We're adding 1 plus 8, or adding 8 to 1. We've got the sum of 1 and 8. There's so many different ways that we say this. 1 increased by 8. Then we've got division, usually divided by is pretty standard. And then 3. So let's look at this. Some other words for addition. We've got plus, means the same as addition. Subtraction. Another word for subtraction is minus. Of course, multiplication is the same as times, and division we use divided by. This is all on your online textbook, so you are welcome at any point to go back. I'm going to be skipping the extra examples, but you are welcome to go there on your online resource and you can try them and it will tell you if you get the correct answer. So that's a great way for you to try some of these on your own. So then it says translate a verbal expression with grouping symbols. So we have the sum of 5 and 9 divided by 2. So when we have these parentheses around the 5 and the 9, that tells me that that's put into a group together. That means we have to take care of it first. Well, this grouping symbol, this is very important to realize that the grouping symbol of the parentheses can also be rewritten as we can write that what's in that parentheses on top, because that entire group of things is being divided by 2. So that if you look at the translation down here, the translation is 5 plus 9 all over top of 2. That entire quantity, 5 plus 9, is being divided by 2. Let's try one more. So bowling. A person's handicap in bowling is usually found by subtracting the person's average from 200, multiplying by 2, and dividing by 3. Marley's bowling average is 170. Write a numerical expression for Marley's handicap in bowling. So it's important to understand what we were reading. What are we trying to find? We're trying to find her handicap. How do we find a handicap? So let's go back up here and read again. A person's handicap is usually found by subtracting the person's average from 200, multiplying by 2, and dividing by 3. So if her average is 170, we subtract that 170 from 200. So we're going to fill this in. Then it says to multiply that by 2. So we're going to do 2 times that entire quantity. We had to do the subtraction first. And a lot of times kids can come, or students, you're not kids at this point, you're in high school, but students can come up with, I lost my train of thought. There was an interruption. But anyway, back to what I think I was saying. Students are always capable of doing these types of problems. They're capable of giving me an answer. But at this point, I don't want just an answer. I want to see how you got it. I want to see the critical thinking skills that were involved in getting this answer. So write down what you did, just like we did here. We took the 200, we subtracted Marley's average, which was 170. Then next, we have to multiply that difference by 2. So we put the 2 outside of the parentheses, because that whole answer, that 200 minus 170, got multiplied by 2. Then next, after we do that, we take that entire answer and we divide the entire thing by 3. And that will give us our answer. So we will do the parentheses first, then the multiplication, and then last of all comes the division to get our answer. Sometimes they throw exponents into the problem, so we have to look at where those come into play when we're evaluating a numerical expression. So again, the base is the x here, and the little tiny number, the little n, is our exponent. We refer to the whole thing as a power. A lot of times people just refer to the whole thing as an exponent, and I'm really guilty. I think I even did that earlier in this video. I'm guilty of doing that myself. Like, take care of exponents first. And then that kind of makes it sound like we're doing this whole thing. But the exponent refers to the little number. The base is the big number, and the entire thing all put together with the base and the exponent is referred to as a power. So when n is a positive integer, once again, the exponent indicates the number of times the number is multiplied by itself. So if we have 7 to the first power, that means 7 is only being multiplied by itself. It's just 7. We're not multiplying it by, it's not 7 to the second power where it would be 7 times 7, but 7 to the first power just means I have 7 one time. So to evaluate an expression means to find its value. If a numerical expression contains more than one operation, then the rule lets you know which operation to perform first by doing order of operations. So first we evaluate expressions inside of grouping symbols. You guys have probably heard PEMDAS, or please excuse my dear Aunt Sally, or I can't think of all the other ones that I've heard throughout my teaching career, but it's order of operations. We do the parentheses or the grouping symbols first. And it's important to realize that grouping symbols is more than just parentheses. Like if you think back to that problem where we had the numbers on top over top of 2, there's no grouping symbols there, but all of those numbers are grouped together. So we take care of that first before we do the division. So then the second step is to evaluate all powers. Anything with an exponent. We always say parentheses, then exponents. We take care of anything with a power. Step 3 is to multiply and or divide, whichever comes first. If multiplication comes first in the problem, reading it from left to right, we multiply first. If division comes first, then of course we would divide first. Then you know next is to add or subtract. So as before, we've talked about this. Please excuse my dear Aunt Sally. Parentheses, exponents, multiply, divide, add, subtract. It's the same thing. This is just going a little bit more in depth on the explanation. So quickly, let's look at this. 2 to the 4th power is the same as 2 being multiplied by itself 4 times. 4 to the 5th power is the same as 4 being multiplied by itself 5 times. Now that we've recapped what order of operations is, let's use order of operations to drag the appropriate justification next to each step. So what did they evaluate first? We have 20 minus 7 plus 8 squared minus 7 times 11. Well, we know if they're following order of operations first, you take care of grouping symbols first. Our problem has no grouping symbols. So the next thing we have to deal with is the power. So what is the power here? We've got 8 squared. I would love it if you would pause the video here and in your notebook, work this out. I want you to just number it 1, 2, and 3 and write the correct answers in, and then unpause and we'll check it. So we can see that first they evaluated the 8 squared and got it to be 64. What did they do next? Well, if they're following order of operations, once again, after we take care of grouping symbols and powers, we know that we should multiply or divide whichever comes first. So if I'm looking at this box up here, do I have any multiplication or division? Yes, I do. I have this 7 times 11, and it's tempting to say, just ignore the minus, but I like to look at that as a whole and think, when I look at it, don't think of it as 64 minus 7. I look at that as, just by itself, it's a negative 7 times 11, which is negative 77. I guess no matter which way you look at it, you're going to get the same thing. If I had 7 times 11, I get 77, and then just drop the minus sign down. That works too. So they multiplied 7 and 11. In our next step, they began subtracting and adding whichever came first as they moved from left to right. So we can see that they subtracted 7 from 20 and got 13. And then last of all, they added the 13 and 64. And then subtracted and got 0. So we have the correct answers. Once again, you can get on your online textbook. There are problems for you to try this on your own, and I highly recommend that you do that. Again, take a second to pause the recording and to try this on your own and see if you can come up with the correct answer. Okay, I did my power first. 2 squared is 4. Then I did the 8 divided by 4, taking care of that division, and I got 2. So 16 minus 2 is 14. 14 plus 14 is 28, and that is the correct answer. Okay, I'll try to make this our last example and go through it briefly. But with grouping symbols, we've got 2 groups of grouping symbols here. We've got the top and the bottom. So we want to take care, it really doesn't matter, but I want to go ahead and take care of the top first. So we're going to take care of what's inside that parentheses. That 4 plus 5 is 9. And take care of also that 7 minus 4, which is 3. So then what we have is the power to take care of, that power in the numerator, which is that's the top number. So we've got 9 squared. 9 squared is 81. So now we're going to take care of the multiplication in the bottom. 3 times 3 is 9. So then last we can just divide. 81 divided by 9, and we get 9. Okay, same thing in part B. They took care of the innermost group first. This 3 minus 2 is 1. Then they had to square that because that's still inside of this grouping. So 1 squared is just 1. 10 plus 1 is 11, taking care of what's inside the grouping symbols. So then they had 15 minus the 11 plus the 6. We can go ahead and subtract that 15 minus 11 and get 4. Then we add the 4 plus 6 and we get 10. So that completes this video. It's a little bit lengthy. I will try to make them a little shorter than this in the future. Thank you and have a great day.